Hello and welcome to the last part of the lecture on a brief overview of Java. First, we'll talk about generic methods. Generic or parameterized methods and classes are fairly common in many object-oriented languages, including Java. First, here is a motivating example. So let's say you want to print out elements of an integer array, right? You could write a method like this, call it, say, print integer array, pass it an integer array, and then run a loop for int I equals 0 to I less than that array's length, I plus plus, and inside the loop, you extract the element, the ith element of the array, integer item, and then print that item. Okay. All right, now let's see you want to print all the elements of a string array. You could write a code like this. What is the difference? Well, nothing apart from the integer in here is replaced with string in here. Integer in here is replaced with the string in here. And this doesn't necessarily have to be like that, but the integer in the method name is replaced with string in the method name. But yeah, the first two you'll have to replace. But apart from that, the code, the two code pieces are identical. So can we somehow leverage some language constructs and have code reuse? The answer is yes. So this is how you can do that. You can create a method, and instead of using a particular type, you can use a placeholder like this. So specify the placeholder type t in angular brackets and then use it in the parameter list. Also use it when you extract the element. And that's it. You have a generic method. We can use it through this example calling code. Let's say you create a string array, phone OS, which has Android and iOS as array elements, and you call print array. This generic method. Compiler will figure out that you are sending it a string array. You could also create an integer array, say primes 2, 3, 5, 7, and pass that to the print array method, which is again the same print array method, and compiler figures out this time you are using integer array and not string arrays. Before we go to generic classes, a small point. So remember when we discussed wrapper types, we said certain places Java must use reference types and it cannot deal with the primitive types. So this is the example and perhaps the main reason why Java went with wrapper classes. So you could not use the print array method with, say, an int array. You have to have it use an integer array. All right, moving on to generic classes. So a generic class is the one which has most, if not all, methods using a generic type, and the methods are written such that they are independent of the specific type. Very common with collections. For example, a queue, queue of integers or a queue of strings or queue of anything, queue of students, queue of games, or whatever you want to use, queue of customers, queue of vehicles. The behavior, the core behavior of the queue data structure, that is enqueuing, dequeuing elements and finding the length, is independent of what the queue is of, right? So such data structures should be implemented as generic classes. So we can leverage all the code written at one place. So here is an example. By the way, once you specify that generic parametric type in the name of the class, you don't have to specify it at each level. In fact, you cannot, it will be a compile time error. By the way, the T doesn't have to be a T, it's just a convention that Java uses. You could spell out type over here, you could have some other name, lowercase, uppercase, doesn't matter. But yeah, T is a convention. In many collections, you'll find the capital E, which means element. Anyway, so this is a queue generic class, and this is how you can use it. You can create a queue of strings like this, give it some name, and then say new queue. Now here you can leave the angular brackets empty, and the compiler is able to infer that you mean a queue of strings, because that's what it was on the left-hand side, or in the declared type. Anyway, then you can enqueue certain strings on the queue. If you want to create a queue of vehicles, it's again exactly the same. Queue of angular bracket vehicle, some name, then a new queue, and then you enqueue a new vehicle, and you could of course dequeue and get the value in a vehicle object and so on. Okay. So it's important to know the syntax, because we are going to use a lot of generic classes. I mean, Android uses a lot of generic classes and generic methods. All right. Next is the Java Collection Framework, often abbreviated JCF. JCF is basically a rich library which lets you manipulate a lot of data by providing very common data structures and algorithms. So it is a rich set of generic types and operations. And basically, there are three things. There are interfaces like lists, iterables, and sets, and maps, and so on. And then there are many of these interfaces are implemented in the implementation classes. For example, you have array lists and linked list for the list. You have hash set, tree set for the sets, and so on. And then you have algorithms like sort, which takes one of these collections and it sorts the list based on how the T compares its objects. One point before we move on, the iterable interface provides a method iterator, which allows for visiting all the members of a collection, like a list or a set, and then you can use what's called a for each loop, which is a simplified a syntactic sugar for visiting all elements. So this loop here reads, for each T item in list, print the item. So a very concise form for, let's say, printing all the elements of a list. We have just mentioned JCF here. It's practically impossible to go into all the details of the JCF framework. But yeah, the link on the second slide is a good resource to start learning about JCF if you are not already familiar. Okay, the last part is callbacks. So any graphical user interface method or framework allows the user to click on any button that is presented or interact with the system in any other way. So what really happens when you click on a button in an app, right? Is there a main method that is waiting to check which button is clicked? How will that work? If there are, say, 10 buttons, let's say a calculator app, 10 buttons just for digits, then a few more for operations. So let's say 15, 20 buttons. How does the main method know when the user is going to click which button? There is no sequential execution. Like you cannot force the user to click a 0 after a 1 every time. So the user can click any of these buttons. So how does it work? It works by implementing what's called the observer pattern. So all the widgets are those elements of view which can interact with the users. So all widgets, they register what's called listeners. Listeners are methods or functions that will be called when something happens on this widget. So when an event like a button click or a swipe or a long tap happens on a widget, its corresponding listener is invoked. And that is the key idea here. And that's very important for Android programming, because all the button clicks will be implemented using such listeners which implement the callbacks. Okay? So here's an example. So before Java 8, before starting with the functional approach, integrating functional programming in Java, you would implement it using what's called an anonymous inner class. So the buttons have a method set onClickListener, which are supposed to get a parameter of type onClickListener, and onClickListener is a class in which you implement the method onClick. Okay. So instead of creating a separate class onClickListener and then implementing the method in it and then passing the object, what you do is you create this anonymous inner class. You simply do new and then onClickListener and implement the onClick method right there. It's anonymous because, well, you never named it. You just created it on the fly over here. Okay, but the key point here is you write the code for whatever you want to do after the button click inside this onClick method. Now, this onClickListener and the onClick method signature are all part of Android framework. Looks a bit cumbersome, but that has been the go-to way to implement such things in Java. With incorporating the functional aspect, this is how you would do it, significantly cleaner. And I personally prefer doing it this way. So what you do is you simply do, you have to do button.set onClickListener, but you don't create a class and then say we are overriding onClick. You can simply do it the functional way, where you have the parameter and arrow which says, for this parameter, this is the method body to be invoked, and then have the code right there. Okay. So that's all I have on our overview of Java. As I said in the beginning, there is a lot in Java that we have not covered, but that is by design. For someone with experience in other object-oriented languages, it should be easy to pick up Java at this point. And if not, go back to any good book on Java or any online resources and get up to speed. Okay. All right. Thank you. We'll stop here. And next time we'll talk about what are the elements of an app. So starting with the Hello World app that you have created, we'll dissect into it and see what are the elements of or key components of an Android app. Okay, thank you.